Okay, the last video ended. I didn't notice that it ended, but I wanted to just refresh on what we did on this problem. We took the original q, found the first derivative and the second derivative. We took the original f function, found the first derivative and the second. Now we started the second derivative because that was the easiest, and we set second derivative at 0, which was 2a, equal to the second derivative of the function at 0, which was excuse me, -1, and we solved for a and got this. When we set the first derivative of it with the a plugged in at 0, the first derivative just equaled b. The first derivative of the function just equaled 0, so b was 0, right? And then finally, we took the q at 0, which turns out it was just c, equal to this function at 0, which is 1, so c equals 1, and this was the final function. All right. So to compute the derivative of each of these functions, do not simplify your answer. So there's a few things here we just have to commit to memory, right? Like we know that the derivative of the sine inverse is 1 over 1 minus x squared, right? But we have to notice here our x is x squared. So the derivative, if f of x equals sine inverse of x squared, right? So the x is x squared. The derivative equals 1 over 1 minus our x here was x squared. So let me write that a little better. X squared squared, right? And then, by the chain rule, the derivative of that inside, which is 2x. So we just put it together in one thing. It's 1 minus x to the 4th with the 2x in the numerator. All right, g of x is e to the x cosine of 2x. All right, we got the power rule as well as the chain rule. Not the power rule, I'm saying the product rule. So f prime g plus f g prime. So the derivative of e to the x is e to the x times g plus e to the x times the derivative of cosine, which happens to be negative sine of 2x, times the derivative of the inside, which happens to be 2. And you're set. Okay? Now, this one up here is I'm surprised he gave it to us like that. I thought it was kosh. Basically, I'm going to go to a blank page. Actually, I'll take this page. I think in the test itself, oh no, he didn't. He gave us that. In one of the homework problems, he said, okay, if h of x equals e to the x plus e to the minus x over 2, oh, I see. He's kind of tricking us. This actually is kosh. I'm going to call it cosine hyperbolic of x. And we do know that the derivative of cosine hyperbolic, apparently, we have to know that, is sine hyperbolic, right? And then sine hyperbolic is equal to e to the x minus e to the minus x over 2. We would get that answer if we did this. So let's say I rewrite this as 1/2 e to the x plus 1/2 e to the minus x. Notice what we get. We're going to take the derivative now. So the derivative of 1/2 e to the x is e to the x. The derivative of e to the minus x, remember, is minus e to the x, so say minus 1/2 e to the minus x. And if we rewrite that, pull the 2 in the denominator, this is e to the x minus e to the minus x. All right, so I guess we probably make sure we know cosine hyperbolic and sine hyperbolic. Those two are derivatives of each other, and they're only different by one sign there. Okay? All right, it says in number 6, determine the interval where this is increasing. Well, the thing to notice about this function itself, never you can never take the natural log of 0 or a negative. So for this function itself, the domain is greater than 0. So that'll affect us a little bit as we move forward. So we take f in derivative. So derivative of x is 1 times the natural log of x plus x. Derivative of natural log is 1 over x. So it's natural log of x plus 1. So we want to know, where is this decreasing? So where is this thing negative? Let's see. So this derivative is 0 equals 0 when x equals e to the minus 1, because watch, natural log of e to the minus 1, these are inverse functions, they cross out, right? Plus 1, or negative 1 plus 1 is 0. So it's 0 when x equals e to the minus 1. And if we do this, e to the minus 1 really is 1 over 2.7 blah blah blah, right? So it's a 1 over 2.71, so a little less than one, little more than 1/3. So that let's just throw it at 1/3 for a second. If we look at 0, guess what? We can't take the natural log of 0. We can't do it. So slightly above 0, this thing will be, it's less than 0 when x is less than this. So it's less than 0 there, and it's decreasing. It's less than it, therefore the f is decreasing from. If it's here, the interval where that thing is decreasing is from 0, because we can't use it, x to e to the negative 1, right? Or 0 e to the negative 1. That wasn't the best explanation, but I think that's the end of this test. Some of these things, for instance, knowing like this, ln of x equal, or plus 1 equals 0. So I'm going to do this. I'm going to say ln of x equals negative 1. Because e to the x is the inverse, I can raise both sides up as exponents on e to the x. This drops out. So that means for this to be 0, x has to be e to the negative 1. That's how I would have figured it out. But you do have to remember that you can't have a log of 0 or any negative numbers. Logs always have to have positive numbers. All right? If you have any questions, let me know.